Hello guys and welcome back to AWS Solution Architect Associate class, and in this video we are going to take a look how many types of stores we can use for our EC2 instance. And number one, that is the instance store available in AWS. And what is instance store? That's basically it provides you a temporarily block level storage for your instance. If your instance shut down, I mean in the stop state, then your data going to be lost. So it's just basically for your uh, temporary based instance store. It's provide you the temporary storage. So let's take a look. So this storage is located on the on disks that are physically attached to your host computer in AWS. And instance store is ideal for the temporary storage of information that change frequently, such as buffers, caches, scratch data, and other temporary content. And you cannot detach an instance store volume from one instance and attach it to a different instance, but we can do it exact same with ABS volume. And the data in an instance store persists only during the lifetime of its associated instance. And if an instance reboots, or whether you just want it or not, and it's intentionally or unintentionally, or there is some issue with your OS and it's rebooted, then data in the instance store persist. However, data in the instant store is lost under any of the following circumstances, if as mentioned below. First is underlying disk drive fails, instance stops. If you stop your instance, that's going to be, then in that scenario your data going to be lost. But in the reboot it's not, but in stops it's going to be fail. If you terminating your instance, then your data going to be lose. And here is the options you can find it when you are choosing your AMI. You can see the two options, that either the EBS instance, you can say the root device type is basically the root device disk in your AWS. When you are choosing AMI, you can select either the instance store or the EBS volume. So there are two options, and in the next slides we are going to take a look what the EBS is. So just don't worry right now. So just keep in mind, instance store is the temporary and your data going to be lost if your instance in stop state or the terminate states, or your disk going to be failures, then your data will be lost. So just keep in mind, okay? But only reboot, if you are just rebooting, then your data will be persist. Okay, so what is the Amazon Elastic Block Store? That's the Amazon EBS, and that's the abbreviation of Elastic Block Store. Elastic Amazon Elastic Block Store, or Amazon EBS, provides block level storage volumes for use with EC2 instance. Just keep in mind is the block level storage. However, S3 is not a block level storage. That is the file level or the object level storage, while EBS is the block level storage. And Amazon Elastic EBS volume, it provides block level storage volumes for use with EC2 instance. EBS volumes behave like raw or unformatted block devices. You can mount these volumes as devices on your EC2 instances. One EBS volumes can only be attached to a single instance at a time. However, you can attach detach from one instance and attach it to with other instance, but can be attached only once at a time. EBS volumes are particularly well suited for use the primary storage for your file systems, databases, or any applications that require fine granular updates and access to raw or unformatted block level storage. EBS is well suited also to both database styles applications that rely on the random reads and the writes, and to throughput intensive applications that perform long and continuous read and writes. With EBS, you pay only for what you use, and EBS volumes are created in a specific availability zone and can then be attached to any instance in that same availability zone. However, you can use into the different availability zone, but there is a different process. But just keep in mind right now it's can be available into the same availability zone. And to make a volume available outside of the availability zone, you can create a snapshots and restore that snapshots to a new volumes anywhere in that region where you are going to access them. And you can copy snapshots those to other regions and then restore them to new volumes there, and making it easier to leverage multiple AWS regions for geographical expansions, data center migration, and disaster recovery. So here is the process. Let's say you have created your ABS volume and EC2 instance into the North Virginia, and then you are going to migrate, or just you want to access your your ABS volume into the Mumbai region in India. Then what you have to do, you have to first you need to create a volume ABS volume snapshots, then restore that particular snapshot into your regions, into the Mumbai region. Then you can copy that snapshots to that regions, and then restore them to new volumes, and then it going to make available into your second regions. And there are a couple of types available in ABS volume also. So let's take a look how many types available. First is the GP2, that's the general purpose SSD volumes available in AWS. Another one is the provision IOPS SSD IO1. Third one is the magnetic volumes. That's the very old volumes, and it's not used very highly. And fourth is the throughput optimized HDD. That's the ST1, and then called HDD SC1. So currently, AWS providing for five types of AVS volumes in AWS. First one is the general purpose SSD, provision IOPS SSD, magnetic volumes SSD, and throughput optimized HDD and cold HDD. And now let's take a look what they are actually, what's the difference between all of them. And let's see, start with first, that's a general purpose SSD. So general purpose SSD volumes offer a base performance of 3 IOPS per GB per gig. It's not actually the GB, it's a GIB, with the ability to burst to 3000 IOPS for extended periods of time. And a general purpose SSD volume can range in the size from 1 GB to 16 TB, and provides a baseline performance of 3 IOPS per gigabytes provisions capacity, provision and capping at 10,000 IOPS. So let's say it's what does that mean is the uh, 3 IOPS per gigabytes provision. Let's take an example. Let's say if you provision a 1 TB volume, you can expect a baseline performance of 3000, because you are going to configure provision 1 TB. 1 TB multiplied by 3, that's the 3000 IOPS. And if 5 TB volume will not provide you, just because there is a capping of 10,000, then you cannot get the 15,000 15,000 IOPS baseline, but it would be maximum, or you can say the up to 10,000 IOPS. So that's how it's work. So whenever you are not using these IOPS, they are accumulated as IO credits, and when your volumes then has heavy traffic, it will use the IOPS credit at a rate of up to 3000 IOPS until they are depleted. At that point, your performance revert to 1500 IOPS. And general purpose SSD volumes are built based on the amount of data space provisions, regardless of how much data you actually stored on that particular volumes. So just keep in mind, it could be a question into your exams that it's going to charge you whatever, if you provision the general purpose SSD of 100 GB, but you are just putting the data only 50 GB. That's you are going to pay. In that scenario, you are going to pay for 100 GB, not the 50 GB of data. And these volumes are ideal for a broad range of use cases, such as the booty volumes of small and medium sized databases and development and test environments. Okay, let's see the second one, that is the provision IOPS SSD. If you require the higher network throughput, then you have to use provision IOPS SSD. So ISD stands, also you just keep in mind, it could be referred as the IO1, is backed by solid state drives, that's the SSDs, and is the highest performance EBS storage options designed for critical input output intensive database and application workloads, as well as throughput intensive database and data warehouse workloads such as HBase, Vertica, and Cassandra. This allows you to predictably scale to 10 of thousands of IOPS per EC2 instance. And when there is need of the input output intensive workload, particularly database workloads that are sensitive to storage performance and consistency in random access input output throughputs, and a provision IOPS volumes can range in the size between somewhere anywhere from the 4 GB to 16 GB. And you when you is when you provision a IOPS SSD volume, you specify not just the size but also the desired number of IOPS up to the lower of the maximum 330 times the number of GB of the volume or the 20,000 IOPS. And a volume can range in the size from 4 gig GIB to the 16 TB, and you can provision from 100 IOPS up to 64,000 IOPS per volume on AC2 instance built on the Nitro system, and up to on other 32,000 on other instances. So let's take an example how it's going to be provisions. So let's say you have configured a 100 GB or the gib volume and with up to 5,000 IOPS. So on a supported instance type, it should be, the instance should be supported. If your instance not going to support that high IOPS, then there is no sense you to configure this provision IOPS SSD. And you on a supported instance type, any volume 1280 GIB in size or the greater allows provisioning up to 64,000 IOPS maximum. So it's how it's calculated. The 50 into 1280 GIB is equal to 64,000 IOPS. That's how it's going to be provisions. Your per IO latency experience depends on the IOPS provisions and your workload profiles. And provision IOPS SSD volumes provide predictable high performance and are well suited for following scenarios where where you are using the business critical applications that require the sustained IOPS performance and large database workloads. So then you can provision IOPS SSD or IO1. Third one is the magnetic volume. That's the old generation backup drives kind of. So EBS magnetic volumes are backed by hard disk drives HDDs and can be used for workloads with smaller data sets where data is accessed infrequently or when performance consistency isn't of your primary importance. Basically, EBS magnetic volumes provide approximately 100 IOPS on average, with an ability to burst to up to hundreds of IOPS and support volumes from 1 1 1 gigabytes to 1 TB in the size. And they are best suited for workloads where data is accessed infrequently, where you are not going to use your data frequently access sequential reads, or situation where low cost storage is also a requirement. Magnetic volumes are built based on the amount of data space provisions. So fourth type of SSD is the throughput optimized HDD, and that's called ST1 also. And throughput optimized HDD volumes are low cost HDD volumes designed for frequent access throughput intensive workload, such as you have to use your big data warehouse and the log processing cases. And volumes can be up to 16 TB with a maximum IOPS of 500 and maximum throughputs of 500 megabytes per second. These volumes are significantly less expensive than the general purpose SSD volume also, and these volumes are basically ideal for large sequential workloads such as Amazon EMR, ETL jobs, data warehouse, and the log processing. So let's just take a note. So why in where when we should use when you create a snapshots of a throughput HDD volumes, performance may drops as far as the volume's baseline value while the snapshot is in progress. And Last one is the called HDD or SC1 volumes. So cold HDD volumes are designed for less frequently accessed workloads such as colder data requiring fewer scans per day. Volumes can be also go up to 16 TB and with a maximum IOPS of 250 and maximum throughput of 250 Mbps. These volumes are significantly less expensive than throughput optimized HDD volumes. So these all are the types available as an in the AWS, and just make sure you understand before sit into the exam. Let's take a look into this chart how they are uh, they use and their use cases, volume types, and their use sort descriptions, use cases, their API names. There's also need you also need to understand or keep in mind what's their API name is, what's their maximum minimum volume size, maximum IOPS and maximum throughput. So can just take a look here. That's the solid state drive. We have two types of the SSD volumes and two types of SSD, and one is the magnetic disk also. So you can just take a look. It's not feasible and a good idea to read each and every one. You can just read it by your own. Okay, guys. Thank you.